Today we discuss trigonometric ratios of 0 degree. Let us see what happened to the trigonometric ratios of angle C. If it is made smaller and smaller in the right triangle ABC, it will become 0. Suppose a triangle ABC. In figure 1, triangle ABC is a right angle triangle in which AB is the height, BC is the base, and AC is the hypotenuse. And angle ACB is theta. Angle is theta. In figure 2, ABC is a right triangle in which AB is the height, BC is the base, and AC is the hypotenuse, and angle ACB is equal to theta. But in figure 2, all the lengths and angles are smaller than figure 1. But one more thing is there. In the figure 1, you look at the BC, the length of BC is larger. But in the length of the BC, in the figure 2, look like smaller. But in both the cases, the length of the BC are same. Now in figure 2, now in figure 3, ABC is right triangle in which AB is the height and BC is the base and AC is the hypotenuse, in which angle ACB is theta. But in the figure 1, angle ACB is something like, suppose theta is 30 degree, and in triangle in figure 2, triangle ACB, angle ACB is suppose is smaller than the theta is smaller than figure 1. Suppose that one is 30, then this is 15 degree. And similarly in the figure C or in figure 3, ACB is theta degree, which are the smaller in the figure 1 and figure 2. Now we discuss in the figure 4. In figure 4, AB is the height, but the length of the AB is smaller than the figure 1, 2 and 3, and also angle ACB is different in each figure, but the length of the BC is the common in every figure. Now in figure 5, the length of the AB is small as compared to the figure 1, 2, 3 and 4, and also angle ACB is very small. Now in figure 6, the length of the AB is smaller as compared to figure 1, 2, 3 and 4, and also angle ACB is very small. It means we can say that the length of AB is equal to 0 and angle ACB is equal to 0. So the value of the sine A is equal to AB by AC is very close to 0. Now sine A is equal to AB by AC, and sine A is equal to 0 by AC, and sine A is equal to 0. Similarly, cos A is equal to BC by AC, and cos A equal to BC by DC. So cos A equal to 1. This helps us to see how we can define the value of the sine A and cos A equal to 0. So what we define, sine 0 is equal to 0 and cos 0 is equal to 1. Using this, we have tan 0 is equal to sine 0 by cos 0 is equal to 0, and cot 0 degree is equal to 1 by tan 0, which is not defined, and sec 0 is equal to 1 by cos 0 is equal to 1, and cosec 0 is equal to 1 by sine 0, which is again not defined.